Good morning, everybody. We are going to be talking about Newton's third law. All right. I wonder if anybody recognized that music there. That's going to be the question for the day. Morning, morning. Hey, Malachi. Hey, Rocky. Good to see you. Good to hear from you. Not see you. I can't see you. There's a little picture there. I am so happy that I don't have to teach or do this on Monday and that I have to do this today. I felt so bad yesterday, but I feel much better today, and I'm really kind of excited to get started with my day. And I'm going to play this song again at the end and see if you recognize it. It's something that my daughter decided she wanted to learn after we watched a movie, and we'll just see if you guys know it. By the way, who do you need to say hi to? You need to say hi to Harold. I'm supposed to use this pointer that my wife got me saying, "Hi, Harold." I don't know how I'm really supposed to use this, but I'll figure it out. So the other day I gave you guys an assignment. If you've looked at it, let me know on the fluid friction project. If you looked at it, yeah, you could use it as a nose picker, but I'm not going to do that on live stream. I guess you can clean out your ears, scratch your back. Brandon, all right. This is the kind of stuff that we really have a lot of fun with towards the end of the year, and I think it's something you can have fun with at home, regardless of what type of materials that you happen to have. You can find something to make a project out, whether it's paper, cardboard, plastics of some sort, garbage bags, grocery bags. Of course, you got to be careful. Things like plastic bags and stuff, if you're goofing around, you can suffocate. So you got to be careful. But did anybody let me know either yay or nay? Yes, that's a yes or no, whether you looked at the fluid friction project that I posted on Google Classroom. And while I'm looking for your response, I'm going to talk about a couple concepts that hopefully will help you get the idea that of what the fluid friction project is. The first thing I'm going to tell you is it really has to do with Newton's third law. That's three fingers. Newton's third law. Wait. 3 fingers. See, I did find a use for that. All right. So Newton's third law states that for every action, there is an equal and opposite reaction. I talked about this the other day. If I hit and I was doing this, matter of fact, over the weekend, I was pitching to a wiffle ball to my grandson, and he was so morning, Joey. And so that's a prime example. You know, this is going to be my baseball bat. of me hitting. I'm going to use this, which is part of my iPhone. So I'm going to have to temporarily borrow this from my iPhone, and imagine that this is a baseball and this is a bat, and that ball is coming in with momentum, right? And I'm gonna hit it, and that's gonna turn around and go in the opposite direction. Well, how come this doesn't go in the opposite direction? The reality of it is there is a reaction, an equal and opposite reaction. It's just probably not as noticeable. However, if you had a high-speed camera that could slow things down, you would see that when someone's swinging the bat, that the momentum or speed of the bat changes once it hits the ball, okay? But only ever so slightly. And so there are changes. They're just very minute. If they were two equal objects of equal mass and traveling at equal velocity, it would be much more obvious how to see the reaction. I will tell you this. As I am learning, I've learned how to post videos, and so I have some videos that will show some of Newton's laws that I'm going to be sharing with you. I think I probably can get a couple of them posted today. Excuse me. But Newton's third law, for every action, there's an equal and opposite reaction. If I bounce a ball on the ground, if I drop a ball on the ground, it's going to bounce back. That's the equal opposite reaction. The Earth actually absorbs some of that. If you could imagine what would happen if a large asteroid came into the Earth and impacted the Earth. Obviously, it would do a lot of damage. Would it actually change the Earth's orbit, the way the Earth is moving around the sun? It probably would. So if the Earth was supposed to move like this, right across where my mustache is, let's say it was impacted by an asteroid coming in from outer space, did it change its trajectory ever so slightly? So it's not up here, but maybe down there a little bit. And so a lot of times we may not be able to notice the equal and opposite reaction that Newton's third law represents. But this fluid friction project is a prime example of how it actually works. Okay, so there's something involved with using or making, for example, making airplanes that involves something called lift. Now I made a little airplane here. One of the reasons why this airplane will not fly very good is because it has very little wing space, very little surface where the wings are. And so for lift to occur, there needs to be an imbalance of air pressure below and above. Remember, air is a gas. It's a fluid. Any gas is a fluid. Liquids are fluids. So even the air around us is fluids. The idea of something that's a fluid basically means that it's not solid and it moves around. And a prime example of this would be if I could produce some heavy smoke right here, and I could take my finger and go like this, you would see the smoke whirl around. If you put food coloring in a glass of water and whirled it, you would see it move around, swirled it, you would see it move around in the water the same way. So understand that fluid and liquid are two separate words, and that a gas can be a fluid and a liquid can be a fluid too. So fluid resistance and Newton's third law, when it comes to this fluid friction project and trying to keep something in the air, we have to talk about air resistance. Air resistance is a form of friction, right? That objects experience as they're moving through the atmosphere. There's friction that's occurring here, right? Frictions, whether you're throwing a ball, whether you're, whatever you're doing, there's friction that occurs that's slowing it down. If there wasn't any friction, this would go on for, it would keep going in a straight line. Real quickly, so let's switch gears. If anybody has any questions so far, let me know, but let's switch gears and talk about what lift is and the idea of lift. And I need a better piece of paper. Let's see, what can I use? Well, this would be a big piece of paper, right? This is last month's calendar. And so if I have this, I know I'm making all kinds of noise. If I have this, what is actually going to keep this from reaching the ground? It's basically, go back to what we were talking about a couple of weeks ago, it's basically an unbalanced force. For this to stay in the air or even go higher, there needs to be more pressure under it than what's above it. What would keep it at the same level, the same height, would be a balanced force. When we were talking about balanced and unbalanced forces, we were talking about like taking a box and moving a box back and forth, and when is it even and uneven? It's even when it's not moving. Okay, when this is not moving, the balanced force is even. If it's moving to my right, that means I'm pushing more with this hand. If it's moving to the left, that means I'm pushing more with that hand. Real simple. So if I have a plane and let's say that this is the wing of the plane, for me to get this plane to go off the ground, I have to have more pressure pushing under it than is coming down from above. So it's a matter of those balanced and unbalanced forces. You absolutely, there could be a mathematical way of figuring this out. But common sense says, and we're not going to do the math on that, not right now. But common sense says, and you guys are all going, shh, thank God, no more math. Except for Raquel, she loves math. So again, we're going back to what we have here. If we want to keep it in the air, we have to have more pushing it up than what's opposite. And so what's actually happening is, I thought I had something I could use for an arrow. I do. Sorry, get my face in the camera. So let's say this popsicle stick is some wind coming up. And so what's actually happening is this air is pushing up against the wing of a plane, right? And it doesn't have to be a plane. It could be a hot air balloon. But what's actually happening is it's hitting that, and then it's pushing down in the opposite direction. Remember I said Newton's third law, equal and opposite reaction. This is the action, air pushing against the wind. This is the reaction, pushing down, which causes lift. Action, reaction. Okay? So the action is the wind pushing, or the air pushing against the wing of the plane. The reaction is that same gas or air or wind, whatever you want to call it, starts to push down and causes that plane to have lift. Does that make sense to somebody? It's actually, flight is one of the coolest things that we have achieved in the last century. And I think we even had a unmanned, I don't know if it was unmanned, but we had a solar plane a while back, if I remember correctly. They actually had a solar plane that was flying, and it all has to do with balance. Now, you guys are going to use any materials you want. Just remember that there's a ratio between and a relationship between weight and lift. Okay, so if I use this is pretty light. Okay, remember, this is what you can do with either throwing up in the air or how far you can throw it. No motors, no anything like that. No gases other than regular air. And so the concept has to be, remember, you want the forces to be balanced at a very minimum, or unbalanced where you have something pushing up more than something pushing down. If something's pushing down stronger than it's pushing up, what's going to happen? It's going to go to the floor. If you have a force pushing up more than what's pushing down, it's going to have lift. Okay? If they're equal, what's going to happen? What happens to a plane? Plane flies in a straight line. All right, so there is a relationship between that and mass. Remember, if it's the heavier your object is, the heavier your project is, the more forces are going to be required for lift. The lighter it is, the less forces are going to be required. Okay, it's got, remember, equal opposite force to cause lift. When air is pushing up on it, it's also reflecting off of it and pushing back down. That's what's causing the lift. For every action, there's an equal opposite reaction. Okay, so the idea is, if you have something that's too heavy, then there's going to be a problem with the amount of air movement that's going to be required to keep it afloat. Boeing, that makes aircrafts, excuse me, they have planes that have 2 engines. They have planes that have 1 engine on each wing and 1 on the tail. That would be 3. And they have, anybody catch that? And they also have planes that have 4 engines. 4. 1, 2, 3, 4. 4 engines. So how did they decide to go from 2 engines to 3 and 3 engines to 4? It really has to do with the mass of the plane. The bigger the plane, the bigger the engine, the more engines. And there's a balance there, right? They actually could have a plane that's too heavy. They could have a plane that's got too big of an engine on it. What's going to happen? The wings are going to bend down. It's going to waste a lot of energy. And it's just going to be a mess. So it's important to have that balance. Remember, this is why we started off talking about balanced forces. Balanced forces help us to know where that point is, and it needs to be an unbalanced force to lift a plane up. And I've always built the worst. I was the guy in the back of the room that was taking notes and watching the other kid in the back of the room throwing a paper airplane to try to hit some girl in the back of the head that he liked. Yeah, that happens. I was never good at building airplanes, and maybe this is my time that I need to work on it. I know, and it's kind of a secret, I know somebody that's working on a really cool project. His name is Mr. Knight. He told me about it yesterday, and I don't know if I think he wants to really share his project. Don't forget, one of the things I want you to do with this is when you get all done and you get your project done, first of all, I want you to time it somehow. You need some sort of a timer, okay? You can use your phone as a timer, okay? The other thing I want you to do too is use your phones and record your flight. This is going to require a camera person. So even if this is your own project, have mom, dad, sister, brother, grandmother, grandfather, aunt, uncle. You can even mount a camera on your dog if you want. Although I don't know if the dog will pay attention as well, but whatever you got to do, I want you guys to record this and then share it. Okay, you should be able to email it as a video. We'll work on that and see if we can do that. If you have your own YouTube sign in, you can post it on YouTube and then you can share it that way. But that's what I want to see, how everybody's doing, who's got the longest lift time period wise. And I think in the end, what I'm really going to do is we'll work on a prize for the best project as far as this goes. I know Mr. Fossilite's going to have fun with this. I have an idea of something I want to work on, and so I'm gonna give it a whirl. It's kind of a large project, and I don't want to let the cat out of the bag, but it is not an airplane. It is more kind of like a parachute, which is what my concept is. And so I hope you guys are having a good day. I miss you all. It's been seems like it's been forever since I've seen you guys, and I know it'll seem like forever before I get to see you guys again. But I do know that you guys that are doing work are doing a good job, and I appreciate your effort. There's not so much work that you can't work on it, excuse me, a little bit at a time. I know one thing I'm going to do, if I haven't done it already. I'm going to post a short little video of our robin's eggs. We were cleaning the gutters and scared the robin off, and she's got beautiful little robin eggs in there. She's still sitting on them. They got to be just about ready to be hatched, and so we're going to keep an eye on that, and hopefully I'll have some video of that too. Do miss you guys. Hope you're having a great day, and I am out. And if you know what movie this song is from, let me know. Take care. Couple more seconds. All right, we're out. Got to push the right button.